Alright, this video is about the application of the 68, 95 and 99.7% rule to normal distribution curves. So what we've got here is a number of different examples where we're going to apply these percentages here. So let's go through each of the examples, and what we're basically looking for is the percentage of the distribution represented by these shaded areas. Okay, now don't forget that really you're not going to get a question like this in the VCAR exam, but it'll be an application of this skill. So doing this stuff here is really important to be able to answer the question you will be asked in a VCAR exam. Alright, so there's heaps of different ways to do this, but I'll just talk you through mine. You might find something that works better to use, but it's up to you. Okay, now this first question here, what we're looking at here is this shaded area. Now the way I'd approach this one is look at what I know. I know that 95% of the data falls between two standard deviations on either side of the mean. Now what I also know is that what's left over after that is 5%. So this part here, and I'll just shade it, and this part here must equal 5. So that means this part only must be 2.5. Okay, so the shaded area is going to be this part here, which we've already established is 95, plus this little bit left over, which is 2.5. So it's 95 plus 2.5, which means that the shaded area is 97.5%. Alright, next question. Alright, not too bad this one. Okay, again I start with, really approach it as what do I know? Alright, I know that 95% of the values fall between two standard deviations on either side of the mean. Okay, so this would be 95%, but the portion we've got here is half of 95. So if I've got 95 and I split the result into two parts, I get 47.5%. Okay, so the shaded area here, this part here only, must be 47.5, doubled 95. Alright, again this one's not too bad. What we know is that 100% of the values fall under the normal distribution curve. Okay, and this is looking for all of the values to the right of the mean. Okay, and the mean is the 50% marker, or the middle of the data, so that means that 50% of the values are going to fall above the mean. Next question. Alright, this looks familiar, and it's just basically a reflection of I think question B. Alright, again, what do I know? I know that 95% of the data falls within plus or minus 2 standard deviations of the mean. So this here would be 95% of the data. So this is half of 95. Okay, so again, if I do 95 divided by 2, I get 47.5%. Okay, so this is 47.5% of the data. Okay, just this part here. Alright, okay, let's have a think about this one. Okay, yep, good strategy on this one is to look at what you know. This part here to the right of the mean is just that question up above, that's 50%. Okay, so we've got 50% there, but we've got this little bit here. Well, what do I know? I know that one standard deviation to the left and right of the mean is 68% of the values. Okay, so if I half 68, what I do is I get this bit here, which must be 34. So I go 50 plus 34 means that that normal distribution curve covers 84% of the data. Okay, let's check this one out. Alright, and I think we've done one similar to this already. One standard deviation to the left and the right is 68% of the values. Okay, now what we're going to do is tack this bit on here. Okay, now here's my approach with this one. I know that 2 standard deviations to the left and the right of the mean is 95. Okay, so see if you can handle what I'm going to do here. I'm going to do 95 take away 68, and I'm going to get 27. Okay, now that means that 68 and this will equal 95. So 68 and 27 is going to equal 95. But I don't want that bit and that bit, okay? I just want, where is my stylus gone? There it is. Okay, I just want this bit only, okay? So what I do is I go 27 divided by 2 is 13.5. This bit here alone is 13.5. So now I go the 68, 1 standard deviation to the left and right, plus this extra 13.5, which means in total I've got 28, 68, 78, 81.5% of the data. Alrighty, this one here, okay, it's really similar to the last question, okay, but really what I know is that 2 standard deviations to the left and right is 95% of the values, okay, but we don't want the 68, it's not included. So from the 95 we're going to remove 68 and we get 27, okay, but that would leave these 2 bits shaded, okay, and I only want one of them. So again what we're going to do is split the 27, which means it's 13.5, so this here must be 13.5%. Okay, this one here is easy. Alright, 1 standard deviation to the left and the right is 68. This is only 1 standard deviation to the right, which means it's half of 68, 34%. Alright, and the last one here, I think we've done one similar to this as well. Okay, I know that 1 standard deviation to the left and the right is 68. Okay, 2 standard deviations is 95. Okay, so what I do is I go, I've got 95, I'm going to remove 68 from 95 and I get 27. 27 is this bit here and this bit here. But I know one of the bits. Well, it's a normal distribution curve, which means they're balanced on both sides, which means I can go 27 divided by 2 is 13.5. So this bit here is 13.5. I'm going to go 13.5 plus 68 equals 81.5%. Okay, so that's the normal distribution curve. That skill there is just so important. You'll guaranteed get a question on the application of that skill at some point in the examination, and working through these problems and practicing them will really make sure that you're going to be fine with that.